Welcome to Easy Gates Gate 22 Instrumentation Paper Solutions. Next problem, question number 46 from Digital Electronics. Based on sequential logic design. So we have two D flip-flops. A synchronous design, all the flip-flops are driven by the same clock. Q0 goes to Q1, Q1 goes to Q2, Q1, Q2 drives the D0. That's what given. That's a given digital circuit. So let me get the inputs. So based on that, we'll play. So the problem statement is this. So for the given digital circuit, what is your comment? Okay, so it is given like it's a divide by 5 counter, divide by 7 counter, 8 counter, and doesn't function as we expect, something like that. It is given. Fine. So let me go for the inputs. So call this as, it's already given Q0. Let me call this as a D0, and this is D1, and this is Q1, this is D2, and call this as a Q2. So Q1 and Q2 drives this logic from combination logic. So the result is going to be Q1 or Q2 the whole bar. Okay, that is the one driving D0. So the point is, who is exciting D0? D0 is excited by Q1 or Q2 the whole bar. NOR gate it is. Okay, yes, then what about D1? D1 actually connected to D1 connected to Q0. D1 connected to Q0, and then D2 connected to Q1. So D2 connected to Q1. Okay, yes, what it mean? So it is nothing but, it's a characteristics of D flip-flop is Q star is equal to D by the time the clock edge arrives. So positive edge triggered flip-flops. Okay, so now you can also perceive the problem like this. So it is something, it's a like a register only it is. So you can have a 3-bit content in the register. The first content is Q0, the second content is Q1, and third content is Q2. So we have Q0, we have Q1, we have Q2. So what actually happens in this means, so based on the understanding of your characteristic equation of your D flip-flop, so Q0 data goes to Q1 because of D1 connected to Q0, and the Q0 Q1 star is equal to what? D1. So D1 is connected to means it is connected to Q0. Okay, so therefore Q0 goes to Q1, Q1 goes to Q2, and this Q1 Q2 combinedly delivers the data to this. Okay, so here we have a NOR gate. Yes, that's how it is given. Okay, so that's how we can pursue the problem. So we'll play like this. Q0, Q1, Q2. Okay. So who drives this means Q1 and Q2 drives this. Q0 goes to this, Q1 goes to this. So any initial condition given means, so no initial condition given, you can happily begin with the 0 initial conditions. Even you can try the reverse. Okay, so you can also conclude with that. So let me begin like this. So assume the initial states are 0, 0, 0. Initial states, all zeros, I'm assuming. So it's about divided by what counter or what modulo counter it is. Okay, so how many finite states we have in this? So 0, 0, 0, 0 taken. Okay, so then, so this is going to be your D not exciting this. So what will be this data? This is 0, 0, 0. So then this is 0. So what is the next state? We'll go for the next state. So it is going to be Q0 star, Q1 star, and Q2 star. So this is a present state. Take this as a present state. This is your next state. Excitations, you can have D0, D1, and D2 as a synchronous sequential logic design. Okay. So what is D0? D0 is Q1 NOR, Q1 Q2 NOR. Okay. So D1 is connected to Q0, D2 is connected to D2 is connected to Q1. Okay. Yes. We'll take this. Yes, now the initial state is present state is known. It's a present state, present excitations, and the next state. That's how we're going to split the table. A default synchronous design or analysis table. You can play with this. So before the arrival of the first clock edge, let us get the excitations first. So Q0, Q1. So it's looking for D0 is looking for Q1, Q2. So both are 0, 0. So 0, 0, 0 or 0 is 0. Its whole bar is 1. So this is going to be 1. And D1 is going to follow Q0. And okay. So D1 is going to follow Q0 means it is 0. D2 is going to follow Q1, that is also 0. So that's a initial excitation. So now present the first clock edge. So then the state transition is from all zeros to 1 triple 0 as it is, because Q star is equal to D. Whatever your excitation, that is your next state. Simply copy your excitation to the next state. Okay, that's the next state after arrival of the first clock. So now what is the present state? The present state is 1 triple 0. So then what is your D0? It is 0, 0 again. So it's 1. So then D1 is Q0. It is 1. So D2 is Q1. Okay, D1 is Q0. It's 1. So D2 is Q1. What is Q1? Still 0. So then begin. Give the next clock. Then the state is going to be 1, 1, 0. Okay, that's the next state. So then 1, 1, 0 is your present state. So then what we get? 1, 0, the whole bar. Okay, it's 1, 0, the whole bar. It is going to be 0. Then D1 follows. D1 follows Q0, that is 1. D2 follows Q1, that is also 1. So the clock arrives. Next clock arrives. So then the state is going to be 0, 1, 1. Okay, you feel like this. This is going here. This is going here. So this is going here. This is going here, like that. And this is the only one getting the new data. Like that also we can play. So let me take this statement. Okay, the state assignment 0, 1, 1. So before that, so 1, 1. Nor anyway it is going to be 0. So then D1 follows Q0, that is 0, and D2 follows Q1, that is 1. So then apply the next clock. Result is going to be 0, 0, 0, 1. We have not yet recycled. We'll go for the recycling soon. So then 0, 0, 1 is the present state. So 0, 1 will make it 0. So then it is 0 and 0. Okay, it's ready. Next clock arrives, then it is going to be the state. So where you started here, then after how many clock pulses you're going back to this? Yes. Then what are all the finite states? Okay, we have, this is the finite state, this is the finite state, 1, 2, 3, 4, and 5 finite states. So this is a mod 5 counter. That's all. It's a mod 5 counter. Even you can focus on only your Q1, Q0, or Q2. You can see that. So the frequency is, that means in 5T clocks, you will get only one cycle for your Q0, Q1, or Q2. Therefore, we can happily conclude what? It's a divide by 5 counter. Okay. So the answer is straightforward. So it's a mod 5 or divide by 5 counter or modulo 5 counter. Okay. That's a simple sequential logic design problem given in instrumentation paper. So probably most of the gate aspirants might have connected to this, okay, easily. So thanks for watching. Do subscribe our channel. We'll update you with the next problem.